This is Steve Piloff from George Mason University. If compounding takes place annually, then the APR equals the EAR because compounding takes place every year, and so the rate for a year captures all compounding, so they're equal. However, if compounding occurs more often than once per year, takes place semi-annually or quarterly or monthly, then the EAR is greater than the APR. There's the effect of interest on interest. And in fact, the more frequently that we have compounding, the greater the EAR becomes for a given APR. So we saw that when we had 8% annually, it was corresponding to 8% EAR. But when we had an APR of 8% with quarterly compounding, it corresponded to 8.24% because of the interest on the interest. And if we had done this exercise with monthly compounding, then we would have gotten a number even greater than 8.24%. So somebody who's really smart might say, wait, if Dr. Piloff just said that, then I work at a bank, maybe we should compute, on our loans, interest on interest every day. And then someone else might say, well, let's do it every hour. Let's do it every minute. Let's do it every second. Let's do it every millisecond. And so as you get to more and more frequently doing just tiny bits of interest on, the principal, you can keep going until the limit you get to something called continuous compounding. And that's where you get continuous compounding. The way to think about it is that you're constantly interest on interest, interest on interest, interest on interest, blah, 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 blah. And in the limit, that's what you're getting. And so there's no periodic rate because there's no period. There's an infinite number of periods. So you can't attack figuring out the EAR by saying, okay, what's the APR? Let's divide it by, 28 billion because, there's more than 28 billion. It's infinite. So you have to figure out the EAR by using E, which is button on the calculator, usually associated with the often associated with the natural log button. But E's roughly equal to about 2.71828. E to the power of the APR, and that's entered as a decimal format. And then you subtract out 1, because E to the APR would capture, if I had $1, E to the APR is how much I would have after a year if the rate was APR compounded continuously. Pull out the 1, and you're left with just the rate part. So suppose you had 18% with continuous compounding. E to the 0.18 minus 1. $1 if it was invested at 18% continuously compounded. At the end of the year, it would be worth $1 and then 19.72 cents. Pull out the 1 and you would see that your wealth went up 19.72 cents or $0.1972 or 19.72%. For a given APR, the highest EAR you can get is the one with continuous compounding. The lowest is annual compounding, assuming annual is the least frequent you can get. And then the more often you compound, the higher the EAR goes, and therefore the highest possible EAR you can get for a given APR is with continuous compounding.